I'm going to talk a bit about Multiarch. I've been doing this as my master's degree this spring, so we actually now have it quite a bit farther than we had when I gave a bit of the same talk a year ago in Porto Alegre. So, okay, we'll start with basically this is what I'm going to talk about: what Multiarch is, a new and scary and exciting feature of the package, which Scott, who might be in the room, has spec'd out. Why Multiarch? Because it appears that not everybody thinks Multiarch is a good idea. And why not Multiarch, which probably addresses some of those concerns. A bit about how to do it in the context of Debian. What the current state is, because we actually have a current state now, unlike a year ago. And some questions and hopefully some answers at the end. Multiarch is having programs for multiple architectures installed on your system and working at the same time. It means that if you're on AMD 64, which will be by far the most common use case, you can have a 32-bit web browser with Flash plugins, if you so deserve, while still running binls as a 64-bit program, if you want to do that. In Debian, we're probably not going to make every package Multiarch, because doing that would mean making loads and loads and loads of changes, and it doesn't really make any sense to be able to have both a binls as a 32-bit and a 64-bit program at the same time. Nor does it make any sense to do that for SED or anything which does not have a binary interface. So the scope is, oh, there it actually worked. So the scope is to have this Multiarch just for library packages. So you can install programs, but most programs won't have any interest in being co-installable. Some exceptions exist, such as GCC or possibly Perl and stuff which uses plugins. Multiarch consists of two parts. It consists of a file hierarchy standard or policy or whatever, and it consists of a package system implementation. The first we've discussed a bit. You end up with something resembling this, where so you'll have all your i386 Linux libraries in user-lib i386 Linux. You'll have your include files in user Linux i386 Linux. User includes i386 Linux, sorry. The other part of this is getting the package to actually understand that those packages which you install are quite, but not exactly the same. And as we know, the package can't have multiple packages with the same name installed at the same time. RPM can do that, which I think is a very bad idea the way they've done it, but that's another discussion. So the package needs to actually know that those two packages can be installed at the same time, and they have different architectures, and they know that they will be co-installable, which you'll tell them by using a multi-arch :yes field in the system, in the control file of the package. A little bit about the package feature dependencies. This is a feature which Scott has been talking about a bit. It's a bit scary because it changes lots and lots of assumptions. The main reason for doing something like this is once we have loads of derivatives and people change, suddenly you don't have a timeline where you have a version which is less than something. You suddenly have the possibility that a feature is fixed or introduced in, say, some version in Debian, another version in Ubuntu, and a third version in Progeny. So you'll have you can't really have depends on something bigger than that version, because it doesn't make any sense. So this is a proposal. There's no code for this yet, but this might be the way it will be done, where you can actually say, okay, this package needs those features from deb helper. We saw this as part of some of the backports from if you wanted to build OpenOffice on Woody, you had to have you actually had hacked build depends in the OpenOffice package to build depend either on this particular backported package or anything bigger than this version, which obviously doesn't scale at all. It also includes system-provided packages. So libc6 will depend on a magic i386 Linux package, or it will depend on system on i386 and Linux, on i386 Linux, obviously. On AMD 64, it will be AMD 64 and Linux, and so on. The last part here, where it talks about what dpackage shlibs will be doing, that's probably the syntax which will end up in capital Debian /control. So most people will never see that unless you actually tear apart a deb file by hand, or you go into the build directory and look at what the heck is going on there. This has a certain amount of complexity, which probably isn't so good, but at the same time, we've discussed this, and we ended up, first we had an implementation which only did Multiarch, and Scott, who is the current dpackage maintainer, didn't want to just add yet another feature. He wanted to generalize it a bit, and this makes Multiarch a lot easier. It means you can actually say that.
I'm just concerned that the features mechanism also has scalability issues.
Yes, it probably has. You can't have have features for everything, and you could foresee, for example, that you had a feature every time you fixed a bug. So a package could say, okay, I need a deb helper with those bugs fixed, where you would end up with a feature line from here to hell and back. No, we're outside of hell. We're in, yeah, Brendan? Just speak up and I'll repeat it.
I think Jeff Laquia, Rajan, can also speak a little bit to this, but we've had some pretty negative experiences researching and trying to implement, in some measures, dependency solvers for RPM. There are at least 3 out there, and part of the reason dependency solvers for RPM are such hell to deal with is because Red Hat has at least 3 different kinds of dependency. They have package version dependencies like we do. They also have feature dependencies, and then they have a 3rd kind, which I can't remember. File dependencies. That's right. This turns out to be really hellish for problem solvers like the one we have in apt. And I just wanted to build upon Vito's concern by being a little more specific. So, you know.
Yeah, it's a comment from Brandon about having multiple ways to specify depends is problematic for problem resolve or package relationship resolvers such as apt.
I'm saying it's not a theoretical.
One question.
The real world actually sees this in RPM.
Yeah. Sorry, Abba.
Please no core talks, especially if you can't understand. Enjoy and ask for questions in 5 minutes. So I don't know.
Just before you go on, Tollef, so are you also doing, say, for example, a package that's on AMD 64 only? It'll just list, but it still lists, say, i386, or can it, say, list i486 if it's only applicable for 486 or Pentium or things like that?
It hasn't been decided whether this will actually support sub-architectures such as i486, i586, and so on. It's certainly a possibility, yes, but so far the main interest has been around not just architectures which are different enough that you can't mix them freely. Which you more or less can if you have the right CPU for say you have an i686, then you can run any i586 package. So the main interest hasn't been in optimizing everything, because it appears that even though some people claim you get loads of performance increase, in practice, in most cases you don't. So it's only interesting for a very, very small number of packages. Like libc, where you just have libc-i686. Okay, why multi-arch? This is adding a lot of complexity to the system. It's adding complexity to the package resolver. It's adding complexity to the file system. It's adding complexity more or less everywhere. And why the hell are we doing this? We have some small non-portable programs. OpenOffice.org springs to mind, which more or less causes the creation of IR32 libs, which is now more or less the biggest source package in Debian, because it includes the source code of GCC 295, GCC 3.0, GCC 3.3, and glibc x386, and some other small packages, which is obviously not a very good thing, and it means doing security support for those is less than ideal. And
excuse me, I hate to disturb, but if you're going to ask a question, please wait until you get the mic. There's a lot of people here who weren't there during the last talk, and I said this also. But if you're going to ask a question, please wait until the moderator comes with the microphone, so it makes it on the recording as well. Thank you.
the reason for having an OpenOffice like this is, of course, that OpenOffice, for some insane reason, includes assembly code to do its own C++ object thingy, which is totally insane to have in a word processor, but it's there. So this is the reason why we don't have OpenOffice on all our architectures yet, more or less. It's interesting for embedded development and cross-compilation, because then you can suddenly install, if you want to cross-compile onto ARM, you can just tell the system that, hey, I want those installed, and even though I can't actually run them, you can just install the libraries and use them to compile with. It means that you can do the same thing with, if you're on PowerPC, but you want to use a i386 program, you can just use QEMU, and it can actually hook into the packaging system. So your packaging system knows that, okay, I have QEMU installed. I can actually run and install i386 binaries, which is kind of cool.
Has anybody actually done that, or is that just I'm sorry, this microphone thing is completely unworkable. The question, if I can remember what I asked, was, has anybody actually done that, or is it just theoretical?
The framework for doing it is there. I haven't actually tested it, both because I don't have a PowerPC system which runs at more than a snail's pace, and because it's not my main interest. But yeah, certainly the framework is actually there. Proprietary plugins and software, we can try to ignore it. We can try to make it go away, and hopefully it will. But at the same time, people are using Flash. People need Java, where you now have Java on lots of platforms, but not everywhere. So in some cases, people actually do have to use proprietary plugins and software, which only exists for, say, i386 Linux. It also, another point which I forgot here is, for some ports like the mythical i386 NetBSD, Debian NetBSD, it can just have the base as i386 NetBSD. Rest is compat. So you actually just install the your regular game or whatever, and you don't have to have a ports Debian org with 20 gigs of NetBSD software, which nobody uses because the port has 3 users. And also, of course, because we can, it's cool, it's elegant. It's a lot more elegant than the current solutions, which are a mix of using lib64, stuffing stuff into emule IA32 Linux, and having some magic kernel support for accessing that instead of regular slash if this is a 32-bit program. I can see Beta chuckling here. It's a really gross hack.
So I had a couple comments. One was to address Vito's concern. I think there's some additional infrastructure that's needed, because one of the things you can think about is you could potentially have software emulators for a whole bunch of different architectures, and you could have one system that has 4 or 5 of them installed, and you would need to determine kind of what your priority was going to be about when you wanted to run things. So say you have an i386 system with QEMU installed, and it can emulate a couple different architectures. You have to decide, say you're using apt or aptitude or something to install packages, you need to decide which one you want to install by default and set up some preferences to determine, if it's available on this architecture, I want it, otherwise use this architecture, otherwise use this architecture, that kind of thing.
Yeah, and my real concern is that a world we want to live in? Because I've been subjected to systems that have that level of utility/complexity before, and it's not really very fun.
So to repeat what he said, do we really want to solve this problem? Do we want to live in that world? Because it gets horribly complex. And then one other comment about why multi-arch. Most of the things that you pointed out are very useful for people who are on non-i386, because that's where the world is, and it's very useful if you're on a non-i386 platform to be able to run some of these other things through emulation. But the other thing that this will eventually buy us is the ability to migrate architectures. And so maybe someday we can eventually get away from i386 if we have the ability to have a long-term transition between one from the other. If you can have these binary packages installed, you can still rely on all this old stuff for a long time and maybe eventually move off of it.
Okay, so why not multi-arch? It's a lot of complexity. Yeah, it absolutely is. But so is maintaining IA32 libs, which I have been doing together with BDEL for a while. It includes evil stuff like diversions. It includes stuffing symlinks where they shouldn't go, breaking the FHS once in a while or all the time. And I don't even want to think about the security implications, because IA32 libs is most likely, it probably should have a couple of grave security bugs against it, because the source code and binaries aren't updated once there's a new security release, which would mean somebody would have to do a new IA32 libs upload every time somebody did an X or libc or some other small package security advisory, which happens a couple of times in the release cycle. We need to change some core stuff. We need to change the package, and together with the package aptitude, everything which knows what a package dependency looks like, basically, which is a fair amount. It also includes a fair amount of user interface problems, like Matt Taggart was talking about. How on earth is the user supposed to actually be able to tell the system that I want this and navigate this some useful way? Because suddenly, if you have support for 5 different architectures, you don't have the ability to install 20 or 15,000 packages. You have the ability to install 5 times as many, with fun stuff like dependency on across architectures, because in some cases you can have an architecture-specific deb, like say SED, which you can replace with. It doesn't matter whether you're running an AMD64 or i386 SED, because it has only a text interface. But the packaging system has to actually know this and try to decide, or give the user the option to decide on which one he wants. The tool chain needs to change. GCC 4 was fixed last night to actually do on by Arch. It now selects user include i386 Linux or AMD64 Linux based on whether you pass M64 or 64 or M32 to it. glibc, the patch is there. It was supposed to be in Sarge. I don't think that upload ever happened, or at least I haven't seen the bug been closed, so I think it's still missing there. Binutils need some changes. What's amazing about those changes, though, is that I did this as part of my, just a second, Bran, and as part of my master's thesis, as I said, and all this software has been patched so many times that there's actually no source code, no original source code left. It's all patches, which makes it even easier to patch again. So the patches for binutils, for instance, is less than 10 lines. Patch for GCC is on the same scale. So it's actually very small changes. It's just that they're there. Brandon.
Yes, to get back to something you were covering earlier about that you just mentioned again, which reminded me, you said we have architecture OS specific subdirectories of user lib. That I understand because there are elf objects in there. Could you explain why we also need them for user include? Because header files I've seen generally have use the C preprocessor to determine what architecture they're dealing with. So in principle, you shouldn't need different header files for different architectures, should you?
In theory, you shouldn't, but in practice, you often do.
Oh.
Because what you have is stuff like, in some cases, config.h, which is generated by autoconf, gets included into the include tree, stuff like that. So basically, the only cost of not having user include ArchOS is you save a bit of hard drive space. And potentially, you get a lot of headaches instead. So
I've been spoiled by iMake. I forgot about AutoConf.
The last thing, which is kind of covered by the first one as well, but DAC, KT, FTP, Debian org, all scripts which touches that needs to actually change to understand any changes in the pan syntax. I'll be showing. Or I actually showed that up here.
Tollef, can I interrupt for a second? To address Brandon's concern, if you do have header files that are able to that are Arch independent, they can still go on us or include, which will be fine, and that's kind of nice because that way. So ideally, you would push everybody to try and make everything IFTF so that it would work properly, and then in the rare cases where they don't, then you put it in the other place.
Yeah, we're not ripping out any support. It's very important to actually preserve backwards compatibility, which is one of the reasons why we're just adding stuff onto the dependencies and so on, instead of removing anything. Because we need to preserve the meaning of the fields as they are today. So if you have a deb, where the semantic of the depends fields means it's something today, it needs to be the same in a multi-arch world. If not, you can suddenly install a libc6 on your AMD64 system, but this libc is for i386, and naturally everything breaks down, which is very bad.
A lot of this complexity seems to come from the modification of the developer packages and to support cross-compilation to different architectures. Wouldn't there, I can see possible slightly kludgy but much more localized changes that you could do to make it work at runtime only, and that might be a lot simpler.
The main or the biggest complexity is actually in depackage and handling the dependencies and getting those things right. That's much harder than the file system. The file system layout is easy. File system layout is like more or less all interesting software except for X. Some other stuff uses autoconf, which means that more or less you pause that double dash include there and unlib there, and it just works, barring any bugs, of course.
Perhaps binutils and GCC and stuff like that, surely that shouldn't be necessary.
It actually has a built-in search path for stuff like the crt.o and
Exactly. That's the compile time stuff. If you decided that you didn't need it to work for cross-compiling and you just wanted it to work for executing things, then you wouldn't need to patch all of that other stuff.
Well, you would actually have to do that because you can't reliably move a shared object after it has been compiled or after it has been told where it's installed.
You could make the dynamic linker sort it out.
Yeah, that's a nice theory, except that you break it with dlopen, you break it with libtool. There are lots of stuff which breaks on that assumption. Try moving a .la file once, and you'll see it break in spectacular ways. Trust me. Or ask Keyback.
Well, I've not been changing the source code to ld.so.
I have.
Right, now, I mean, if you changed ld.so, which is where all the dynamic linking happens, to look in a different place, then it'll look in a different place, and everything will look in that different place.
Yeah, but you still have to actually have a way to decide whether, so you can install, you could then say that the dev package puts its symlink in userlib, which points to userlib i386 Linux, whatever. And you would still have the problem of what then happens if you try to actually install for both. If you install libfoo for i386 and libbar for AMD64 and you compile something trying to link both.
You'd have to have some kind of thing to convert the package. That wouldn't be very hard.
Sorry?
You'd have to convert the package, either convert the .deb to move the files about, or you could have it done by the installer. Anyway, this is all getting a bit out of hand.
Yeah, actually getting the file system right is not the hard part. It's the package. That's how until somebody fixes autoconf to actually pass those default paths, that's more or less pass that to autoconf and it does the right thing. The other thing we need to do is split packages, which is not so fun because we'll end up with lots of -common and -dev-common packages because at the moment we don't have there's no way that multiple packages can provide the same file. So we're adding a small hack to the package where it can, if you have two packages which provide the same file and it's a symlink to the same place, then it's just ref counted just like the directory today. So you end up with any lib package will have user.doc libfoo or libfoo0 linked to user share doc libfoo0 -common, which includes the copyright and all that stuff, which actually needs to go into the package. That's a hack, but it's the smallest hack we could actually find to do. And we have to provide copyright information and documentation for obvious reasons. The current status. In Debian, we have the toolchain is more or less ready. The maintainers are already fixing their packages, or they have accepted that they'll have to fix their packages at least. Patches are available, and it works quite well. I've been running a system with both some multi-arch and some non-multi-arch binaries for more or less the whole spring, and so far haven't really run into any big problems. Upstream, LSB, FHS, they have a bit of interest in it, but it's mostly along the lines of, yeah, we'll see what Debian does and whether it actually just blows up in spectacular ways, or if it actually ends up being very, very nice and useful. I think and hope we'll end up with nice and useful, and everybody will follow this, because at the moment using stuff like just lib64, it breaks down once you pass two different architectures, which you in some cases do on, especially once you do stuff like Debian NetBSD, where Debian NetBSD MD64 will be able to run like 5 or 6 different ABIs. So, oh, sorry. Questions?
You've already asked them.
What do you, Spark is currently a 32-bit for most packages, with a few packages having both 32 and 64-bit binaries. Have you considered what, or is anybody looking into what what Spark and Multiarch should do?
As far I don't know Spark very well, but as far as I've understood, it doesn't really make any sense to run everything at 64-bit because 64-bit is by far slower in most cases. So basically, what you would end up is having for the packages where it makes sense, you have a Spark 64 architecture, and you provide those, but it doesn't have to be a full port or anything like that. So Multiarch here is we can use 100 years or 10 releases or whatever comes first doing the transition. So we can actually, as long as you have the core support in ld.so and libc and so on, you actually don't have to have, you can change your libraries at a pace and the order actually which you want to. So I would just see Spark as having a Spark 64 port, which just included some small stuff such as libc and PostgreSQL and some other stuff which makes sense to have 64-bit versions of.
Okay. Okay. So my question is, as far as I understood, Multiarch is still in this. At the moment when I started to turn Debian, Multiarch was already to be implemented in the next days. So that's for me the status of Multiarch as far as I can see. And my question is now, when will Multiarch become real in your opinion?
When
will
become
Multiarch be just something normal that we are going to use every day? Do you suppose that we will do that for Edge +1, Edge +2? When will that happen? And how probably do you think that your expectations will be met?
Well, I need to actually check whether the base support went into Sarge, because what we have here is it would be very, very bad if you upgraded your system and stuff started to break. So this will probably have to go across 2 release cycles where we first upgrade support into the base stuff before we actually start moving files into the correct directories. Or they'll at least have to depend on the proper version of libc, because it's an SS slibs change. So I'm not sure you can actually do it because of dpackage. So because you're changing the syntax of the depends field. And so older dpackages, I need to test whether they just go blah, or whether they do something sensible, saying blah blah doesn't really understand this, but we'll try to go on as best as we can. So depending on what happens there, I think we actually need support in dpackage and apt and everything before we can start using the syntax in control files. At the same time, that's kind of it's kind of independent of moving the libraries in the file system, because what you will have if you just move the files, just move the shared objects, you'll have they'll all be in the right places, and stuff will look in the correct place and so on, but you won't be able to install the .dabs yourself. You can't install .dabs for more than one architecture until you have a dpackage which understands it. So, the question from B-Dale was whether we could kind of skip through some hacks and just get this done in one release cycle. More questions?
So then, if there are no further questions, I thank you for your nice and interesting talk, Tollef.
Thanks.
You're still here.